right? What does it mean to have an excess of something?
You have an overabundance.
An overabundance, right? You have more of something than you need, right? You have too much of something. Now, in this case, when it says you have an excess of 3 elementary charges, what that means is that you have 3 more, either 3 more protons than electrons, or you have 3 more electrons than protons, right? That's what that means. So when it says you have excess of this many elementary charges, either means you have either 3 more protons than electrons, or 3 more electrons than protons. Now, to solve this problem is, well, what's the electric charge of 3 excess elementary charges? So what is that going to be then? Well, let's do these steps to solve, right? Because, well, first things first, what is the electric charge of 1 elementary charge? We learned it yesterday. 1 elementary charge is equal to 1.6 times 10 to the negative 19 coulombs. We learned that yesterday. It's on your reference table right here. Right here. On your reference table, right here. Now, to solve this question, what do we need to do? Well, if 1 elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs, what's the charge of 3 of them? And why?
4.8 times 10 to the negative 19.
Yeah, 4 point. How'd you get that number?
Multiply by 3.
You multiply 1.6 by 3. Because if 1 elementary charge has a charge of 1.6 times 10 to the negative 19, then 3 of them are going to have 3 times that charge, right? Makes sense? Hopefully. Any questions? Any questions? Please raise your hand before I move on. Oh, man. All right. Now, this question. Before I read this question, what do you guys remember about something that is possible or impossible? What is it impossible to have? Is it possible to have 2 electrons? Yes, no, maybe so. Yeah, it's definitely possible to have 2 electrons. Is it possible to have? Yes. Yes. It is impossible to have part or half of an elementary charge. You cannot have partial amount of an electron. There's nothing that makes up an electron. An electron is an electron. An electron is essentially just makes up other stuff, but there's nothing that makes up an electron. So you cannot have a partial amount of an electron. So if you think about it, let's say you have one electron, right? You have -1 elementary charge, which means you have an electron. Well, the charge of one electron is -1.6 times 10 to the -19. Well, then 2 electrons are going to have a charge of -3.2 times 10 to the -19 coulombs. And 3 electrons, let me just do 4. 4 electrons are going to have a charge of -6.4 times 10 to the -19. And so what I'm basically saying is that if you have a charge that is a multiple of 1.6, I'm sorry, yeah, that is a multiple of 1.6, then it is a possible charge. So how would we go about solving this, right? So can an object have an electric charge of 4 times 10 to the -19? Well, the first thing you do is 4 times 10 to the -19 coulombs divisible by the electric charge of 1 electron or 1 proton? So is it divisible by 1.6 times 10 to the -19 coulombs? If you divide this, 4 divided by 1.6 gives you 2.5 coulombs. I'm sorry, gives you 2.5 elementary charges. So is this possible? Can we have an electric charge of 4 times 10 to the -19? Also, any object can be charged, by the way. So when we say an object that has an electric charge, it could be anything. It could be your pen, it could be your phone, it could be your mouse, it could be your bottle. So is it possible to have 2.5 electrons? Is it possible for an object to have an electric charge of 4 times 10 to the -19? No, it is impossible. You did the math. You divided 4 by 1.6, and what you got was 2.5. So no, it is impossible for an object to have an electric charge of 4 times 10 to the -19. What you'll find out in the future is that you can indeed break down a proton, because there are things that make up a proton, but nothing makes up an electron. All right, what about 9.6? What about 9.6? Is 9.6 times 10 to the -19 a valid charge, a possible charge?
Yes.
Why?
9.6 is divisible by 1.6.
Exactly. That's really the only justification I need, right? Because if we divide 9.6 divided by 1.6, you get 6, which is an entirely possible number. You can have 6 electrons. But for now, just think of like, if you have a partial amount of something, that's impossible, okay? You cannot have a partial amount of something. It's a scam call. Any questions, by the way? Please raise your hand. Okay, let's move on. This one's a little bit harder. Why 1.6? Because it's not just 1.6, by the way. I didn't just do 1.6. I did 1.6 times 10 to the negative 19. Why am I dividing by that? Because one elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs. And again, elementary charge is either one proton or one electron. This kind of looks like an L. Now that looks like a 1. So one elementary charge is either one proton or one electron. The electric charge of one proton or one electron is 1.6 times 10 to the negative 19 coulombs. And well, if you say an object has a charge of, let's say an object has a charge of, well, this is impossible, has a charge of 2 times 10 to the negative 19 coulombs. That's basically saying, because if you divide it by the amount of protons or electrons, what you're going to get here is you're going to get 0.8 times 10 to the negative 9. I'm sorry, this is not 10. It's going to be 0.8. I'm sorry, this is not 0.8. I'm sorry, that's not 0.8. 1.6, 2 divided by 1.6 is something. $1.35. Oh yeah, that makes sense. 1.5 electrons or protons. You can't have 1.25 electrons or protons. That's impossible. You cannot have a partial amount of an elementary charge. You either have one proton or one electron or whole numbers of electrons or whole numbers of protons. You cannot have a partial amount of something, right? That's why we're dividing it by 1.6, because an elementary charge is 1.6 times 10 to the negative 19 coulombs. All right. If an object has a net negative charge, right? So then there's a net negative charge now of 4 coulombs. So your charge, your electric charge is negative 4 coulombs. The object possesses how many protons or electrons? How many more? It's a grammar error here. So if the net charge of an object, again, any object can have an electric charge. Let's say my pen. My pen has a net negative charge of 4 coulombs. So negative 4C. How many more electrons or protons do I have than the other? So the first step is, well, you have to figure out on your reference table, how many elementary charges are in 1 coulomb of charge? So 1 coulomb of charge has this many elementary charges. So 1 coulomb of charge has a charge of 6.25 times 10 to the 18 elementary charges. And this is a massive number, right? This is a massive number. Basically, what this is saying is that 1 coulomb of electric charge has 10 to the 18 protons or electrons. Think of how huge that is, right? You're basically having 18 zeros. That's basically, well, it's 16 zeros now because the 25 takes 2 out of it. So there's 16 zeros here. What's this, 12? 12, need 4 more. So 1 coulomb of charge has this many protons or electrons, which is not even enough to make up your entire body. That's how many protons or electrons are in 1 coulomb of charge. So, and this is another thing that students get confused about. Well, sometimes students get confused about the units, because I say that 1 elementary charge, which is basically 1 proton or neutron, right? Which is basically proton, I'm not neutron, I mean electron. 1 elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs. But that's an extremely small number. This is an extremely small number. A proton or electron has a charge that is in the negative 19 power, which means that it has 19 zeros. Or in this case, 18, because there's a 1.6. I'll make these zeros smaller because I don't have room. That's what this is. 1 proton or 1 electron has an electric charge this low, this small. This is how small an electric charge of 1 proton and 1 electron is. All right, just to put it in perspective, right? Just to put it in perspective. So 1 coulomb of charge has a lot of protons or electrons. So we figured that out. So if 1 coulomb has this many elementary charges, how many elementary charges we don't measure something like that? You're talking about electric current. You're talking about electric current. And it's a really low number. We'll talk about it. We'll talk about it. It's like somewhere around 0.1 amps. It's somewhere around 0.1 amps. Electric current required. So it's like 0.1 amps, 0.1. 0.1 amps, yeah. Yep. 0.1 amps. You learn about amps later. You'll learn about amps later. So how many protons or electrons are in 4 coulombs of charge? Guys, if 1 coulomb of charge is this much, how much is 4 coulombs?
$25 times 10 to the 18th.
Wait, what?
25 times 10 to the 18th.
Oh, yeah. So how'd you get that?
Multiply by 4.
Yep. Guys, if 1 coulomb of electric charge has this many elementary charges, then 4 coulombs has 4 times as much. You guys get the logic here? And to simplify it, it'd have to be 2.5 times 10 to negative 10 to 19. Yeah. So does this object have a net positive or net negative charge? We're moving on to topic C now, because we still haven't answered the problem, or rather step C. Why is it 10 to the 19? Because I moved the decimal over. So there's a decimal point here, 25 decimal, and I moved that decimal place over. If I'm moving it to the left, I add an exponent. Is this charge negative or positive? This is net charge, positive or negative?
Positive.
No. It's in the problem. It's given to you. It's negative, yeah. It's a net negative charge. Which means, so what does that mean? Does it have more protons or more electrons? It has more electrons, good. Because it's negative, right? If you have a net negative charge, well, you have more electrons than protons. And then specifically, how many more do you have? Well, that's easy. You solve it up here. You have 2.5 times 10 to the 19 more electrons than protons. Because, so here's the thing, right? If your net charge is negative 4 coulombs, you have 6.25 times 10 to the 8, 10 to the 19. I'm sorry, 22.5 times 10 to the 19 more electrons. You have more electrons than protons here. So how many more do you have? You have this many more electrons than protons. Any questions about this? You should, yeah, you should. What you realize is that pretty much like, there's a lot of things that deal with electricity that use exponents, mainly because the values are so small, right? Because you need a lot of something to even have 1 coulomb of charge. Pretty much everything in electricity uses exponents. You can use something that's really small because like negative 19 is an extremely small number, right? In the end, you guys are still going to use exponents a lot. Also, I want to clarify something. Some students might be confused about something. A student asked me in a previous class, well, how exactly how many protons and electrons do you have then? That's not what this problem is describing. Think about it, guys. Let's say I have 5 protons, 7 electrons. How many more electrons do I have more than protons? Please tell me you guys are not stuck with this. How many more electrons do you have than protons? Two. You have 2 more electrons than protons. What about now? Still 2. now? Yeah, and it's still 2. And in each of these scenarios that I gave you, the negative charge would still be 3.2 times 10 to the negative 19 coulombs. So these problems don't tell you how many protons or electrons you have. It tells you how many more of something you have over the other, right? That's what I'm trying to get at, right? That's what I'm trying to get at. Answer this question for attendance. I will give you the link. No need to ask me. I will give you the link. This is your attendance poll question, right? So you have 30 seconds left. You have 10 seconds. You know you can answer in the poll. Good. Impossible. Yep. All right, guys. Hey, should I do your homework? Okay. See you guys tomorrow. See you guys tomorrow.
Bye, Mr. Chan.
Bye-bye.